Very good. Good evening, everyone. We are here at Wolfi's Talks, and yeah, well, let me see. We have 1 minute to go, and as I know, Ralf, you are a seasoned triathlete. So the last minute before the race, what did you do the last minute before the race when you're like kind of in the water before water? You're rather calm, rather nervous when you go on the start line, or how was your last minute before the race?
Always nervous. I think if you're not nervous, you're not well prepared. You need to be nervous. You check your goggles and you think, did I train enough or do I have to do something more? Now it's too late. Check where are my competitors, and then the gun goes off. And mostly the last minute goes like 5 seconds. Bam!
Very cool. So the last minute before Wolfi's talks, you're nervous, but you're well prepared. Yeah, you did everything
I'm
right.
really nervous. It's actually my first video cast I'm doing.
Very good. No, really good. Okay, thank you everyone for joining, and I'm really excited to have Ralf Eggert from DT Swiss. He's a German countryman, and he's a very seasoned triathlete, and he did Hawaii 3 times. He had 2 times a bronze medal in the Olympic distance in Wellington, in Cancun, Mexico, which I think is an amazing achievement. His fastest time in Ironman in road was 8 hours and 28 minutes, which is, I think, absolutely unbelievable. He was racing another German, Thomas Hellriegel, in his time. And so when he speaks about aerodynamic and about performance on the bike, he absolutely knows what he's talking about. So I'm really excited to have you on the show. So thank you very much for joining us, Ralf.
Thank you, Wolfi, for having us here on the show
Thank
today.
you. I'm really excited. Obviously, we're related with DT Swiss over many years, and when we speak to our customers in the shop, it's always about Swiss products. We love Swiss products. We're working with Scott very closely, but then people speak about Switzerland. They speak about the chocolate, which we all love, obviously. We love the watches. We love the cheese from Switzerland, and we love obviously the wheels from DT Swiss. And I have to tell you a good story from this morning. I had a local customer came to the store and he bought a bike, and he had only one request for his bike. He said, I want a nice bike, but I want a special wheel, and I want that wheel with that very special sound. And maybe if you can quickly play us the sound.
I cannot imagine what it is. Might be like this.
Oh, that's the sound we all want
Love
on our
the
bike.
Ratchet sound, huh?
Yes. He said he loves his AMG, he loves his cars, he likes them loud, he likes them special, and he said, listen, I want that sound on my wheel. And we obviously gave him a nice DT Swiss wheel, and he's super happy. Yeah, thank you very much for all these fantastic wheels. We have a little intro video, and Will, our graphic designer, which always makes us look so good and prepares everything so nice, he will play the video, and we will get a bit of an idea what is DT Swiss all about. So please, Will.
Here in Valkenburg.
Very cool.
Very nice. Did you get goosebumps?
Yeah, no, it's really cool. But I'm amazed that there's so many different disciplines you have to cater for. And obviously everybody has a spoked wheel on the bike, but we don't really appreciate really how much work and how much handwork goes into these products. And I was in the factory and I saw people doing and truing and everything. And I think the passion for engineering performance and the passion you guys show to really develop and push the wheels further, push the wheel further every year is really amazing. And I'm really a big fan of your products. We have a few more pictures from the factory and as well how spokes are made, but you can tell us a bit more about the history of DT Swiss and how spokes are made and what it's all about.
Well, actually, the company itself was founded only in 1996, so 1996, so only a couple of years ago. So we had 25th anniversary last year, and so this is only quite a new company in terms of long-term company if you compare it to other industries. But in terms of the bike industry, we're almost a dinosaur with 25 or almost now 26 years in the company. And came from a management buyout from the Drahtwerke here in Biel, and this is where the heartbeats is. So the spokes are actually the first heartbeat of the DT Swiss.
Very good. So it just starts with the wire. You know, when I've seen this machine, and then the machine is a wire, and then it cuts the spoke, and then you bend, and this is real machinery, real hard work, and it's quite interesting. How many? Do you have a number? How many spokes you produce per year?
Oh, we produce quite a number. So we produce quite a number of million year. We produce here in Switzerland. We produce quite a amount of spokes a year. So all in all, it's we talk about 41,000 kilometers of steel wire we use for spokes. And the first picture with the green machine was actually the forging machine, where you have oscillating hammers, and they hammer the spoke material, the steel wire, to a thinner material. When you say a thinner material is not as strong as maybe the thick material, you're wrong, because we compress it, we condense the material and make it even stronger. This one is the machine, exactly.
Very good. Okay, so this is the first machine you said. This is pulling. That's pulling the wire.
No, that's actually the next step. It's a forging machine. So here it's the wire is pulled into the machine. Here we see a normal machine, a normal spoke machine, where spokes either are only threaded, or already cutted, and also they get the final edge, and either in straight pole, or in T-head, or in a straight J-bend.
So obviously the spoke head is quite important. So you have normally a spoke head which has kind of a bend. That's why it's like a J-bend spoke. But now you have developed in the past years as well straight head, where like a hammer head, which is now used on most of the modern wheels, which makes the spoke a little bit stronger overall, isn't it?
Yeah, you don't have the bending, so you can align the spokes better. You can make more aerodynamic wheels, and we even got a new step in introducing the T-head spokes, which is a flat hammered straight pole spoke. So you have the same head almost as the straight pole, but you have alignment. The T-head spoke is hammered flat. So when you put it into the hub shell, it's already aligned aerodynamically optimal. So you get it in the die cut wheels. You have this.
Fantastic! Because obviously it's a problem when you twist the spoke, that obviously the whole spoke twists. And if this is that's a clever idea. Very good.
So when you're truing a straight pull spoke, it can bend. So you have to fix it and then true the spoke. And with the T-head, you don't have to hold the spoke, put an extra pressure on the spoke. So it's perfect aligned for aerodynamics. So there's no compromise on aerodynamics.
Oh, fantastic. I love the picture, what we just saw, with all the ladies working and truing these wheels and make them absolutely perfect. And obviously we know the tools from DT Swiss, where you have these exact measurements, what the spoke tension will be. And what I always thought interesting was that obviously we have straight spokes, which have 2.0 all the way along. And then you have 2.0 at the beginning, at the end, and you have in the middle, you have a 1.8. Why would this be a good thing if a spoke is thinner? Is it not stronger if a spoke is 2.0 all the way through?
Oh, as I mentioned, we are treating the spokes differently. So we have a different machine that exactly puts down pressure. It's called our cold forging process, where we have a thinner spoke in the middle, and the material is compressed, is condensed, and is made even stronger. I always say it's like a little bit like a Japanese sword. It's little more layers. It's more thinner, but it's still very, very strong. So I say this is really a strong spoke. And then we even get it done again. So when we're talking about bladed spokes, about aerodynamic spokes, then we do another forging process which is called the blading process, where we put about 250 tons of weight on each spoke. So from the wire, the steel wire itself, it's basically a steel wire that comes in. Then you have the forging process. It takes sometimes up to 30 seconds, only one spoke. Then you have the blading process additionally. And each spoke that comes out of the blading machine is individually QC'd, quality controlled. So it's a really high-end spokes that go out from us here.
Yes, fantastic. No.
It's the only actually, we are the only office of the DT group where these bladed spokes and also the forged ones are produced.
Okay, very good. No. And you can tell, when you get one of these wheels and you take them out of the box, and you really feel the quality. You feel really the engineered performance of DT Swiss. You can see. And the bladed spoke obviously is interesting for the strength you mentioned, but as well aerodynamically, it's quite a difference. A round spoke, obviously, a cylinder shape in the wind going at the high speed into the wind is obviously a bit of an issue. So what's the benefit here when you have a bladed spoke compared to a round spoke when somebody wants to buy a wheel?
As you mentioned, it's already about the aerodynamics. So when you have a bladed spoke, the aerodynamics is crucial in this direction. So we also look next to the translational drag, which is basically the surface, the body or the bike or the wheel produces. We also look at rotational drag, so of the rotation of the wheel, and the single spoke that creates a rotational drag. So when you have a round spoke, you obviously have a higher drag, a higher rotational drag, which has to overcome by the rider. So when we came out with the first ARC wheels, for example, like 3 years ago, then we were talking about the Aerolite and the Aerocomp spokes, which were implemented in the wheels, and now we reinvented the spokes. So we even made them thinner to reduce the rotational drag again. And the longer the spoke, the more I profit from the rotational drag. So when I'm a road racer, road rider, and I love maybe 50 millimeters deep rim, I have quite longer spokes compared to an 80 millimeter rim, which is actually the most aerodynamic wheel. But when talking about the speed and rotational drag of the wheel, then we can save from the old Aerolite spoke to the new Aerolite 2 spoke 1.1 watt.
Okay.
We are not talking about marginal gain, so this is significant.
That's serious. Yes, that's serious savings. Yeah, very good, fantastic. Yeah. Obviously, everybody who has a DT Swiss wheel and some of the higher ones, you have the Ratchet, and I think this is really one of the coolest things. Not only that it sounds so good, I think as well the technology, and we have some pictures to explain the technology of the Ratchet system, which is different to a paw system. But we will speak, and again, Will, thank you very much. Maybe you pause here, Will, and we can have a look at that Ratchet. And we can see obviously the red line, the second red line with the edges on it. This is where the engagement happens. But Ralf, you can maybe explain a bit more. What are we looking at now?
Exactly. This is where we see the engagement happen. So we here see a new Ratchet EXP hub where one Ratchet is already fused with the hub shell. So it's threaded with the hub shell. But here you see on the red dot, the red zagged line, it's where the engagement happens. So when we have 36 T's Ratchets, for example, then we have, it looks like this.
Yes.
Then we have a full engagement of 36 places.
Yes.
36 T's are fully engaged compared to a pole system where we have 3 poles. Yes. So the engagement angle is in the 3-pole system about 2.58 degrees, and between an 18 T's or 54 T's ratchet, we are talking between 20 and down to 6.6 degrees engagement angle. But here you have a really precise engagement, and it gives you a reliable front push when the crank is pushed forward.
Maybe that's interesting for people to understand. Obviously, when you pedal backwards or you pedal, your crank goes backwards until there's another engagement point. This is the angles we're speaking about, and it's quite interesting. When you come next time to the shop, we will show you. It's interesting on the DT Swiss app how much faster. And I think the biggest selling item in DT Swiss is you have a even closer ratio of adjustment. I think it's 52 teeth.
52 is the highest number we have.
Yes.
And we are just below 7 degree of engagement.
Yes.
Engagement angle, which is really good. So when you're a rider and you do a crits and you go out of the turn and you want to accelerate fast, go to 54. If you're a more a long distance guy, constantly pedaling, it's about 36. 36 is a very good compromise, and it's perfect just for road cycling, honestly.
Very good.
Maybe we can see a little bit more when we see the engagement when we have the idle position. Now we see it here a little bit. So when there's when you stop pedaling, then you have an idle position, and then the ratchets, they spin against each other and they're not engaged anymore. And this is where the sound comes from. So when you have 36 teeth on one side, 36 on the other side, that's the sound.
Yeah, very good. We can see the spoke. We can see the spoke head on the left side, where you can see this hammerhead spoke, which is quite interesting. And on the right side, next to the red ring, we can see obviously a bearing sitting onto the hub. I think it's quite interesting. And obviously we see top and bottom, we see the seals to make sure that obviously the sand and dirt doesn't come in. So yeah, I mean, having this piece in your hand, and we see later, maybe once we have you on screen again, we see the cut sample. This is really an amazing piece of engineering, and I really love it to see it and see the technology. And I think you have, with the new hub, you have reduced quite the number of parts in the hub, which I thought was quite amazing. How you changed the design and how you completely reworked the design of the hub to make it even easier to service, easier to dismantle. I had the pleasure to see one of the first ones to dismantle it and see it. It was really amazing. Yeah. So maybe you can show us the cut sample you have.
So this is the cut sample. Oh, see it here.
Yes. Wow. Yeah. This is really cool.
So you see the bearing on the one side and the other side. So when putting the bearing into the screwed ratchet, we could reach more distance between two bearings, made it more stiffer when you ride. This was the idea. One idea. The other idea was, as you mentioned before, reduction of parts used in the hub. And this is I think we have one picture where we can see how many parts we have less in this new hub.
Okay, very nice.
It's really easy to disassemble, and also the conversion is still very big theme. So when we are talking about Shimano, or we are talking about the SRAM XDR, and also we introduced the new Kampa, N3V, N3W, and so we have always a compatibility on all our hubs. We try to match as many possible and as many brands there on the market.
It's nice if you buy a set of wheels, so you're kind of future proof. If you buy today maybe something with 11 speed, or you have maybe a previous 11 speed wheel and now you want to go to 12 speed, you can change it on most of the wheels. You just change the freewheel body and have to change some of the parts, but I think the compatibility is quite high. The only thing you have to make a call is maybe disc or rim brake. Yeah, but I think as well, rim brake is something you're quite keen as well to. You sell quite a lot of rim brake wheels for the Swiss mountains, and you have a very special brake surface on some of your aluminium wheels as well. So can you tell us a bit about this?
So aluminium is actually still very present in the market. So we have a lot of aluminum rims, and also we serve, as you said, rim brake markets still in the out there. Even though the disc brake is coming now stronger, especially in the road cycling market. But what we did a couple of years ago was a new surface called Oxic surface. And this surface is extremely it's extremely hard, and you can't break it off. So it's not colored, it's just an electronic process where the surface gets fluid and then rehardened, and you only can brake with certain pads. But people love to have these kind of rim brake wheels, especially in the braking when it's going to be wet. I mean, in dry conditions, everybody can brake. As soon as the conditions change, well, some get a problem, or even the brake pads reuse very fast.
Mm-hmm. Yeah, but okay, I think good braking is obviously important, and if you have a bike with rim brakes, then you want to have a set of wheels with Oxic brake surface to make sure you get to a standstill as quick as well. There's another wheel which I love, and I love the story, the Montchachon. Where's the name Montchachon coming from?
I can't see it right now, but it's very close. The Montchachon, the Chasseral is a mountain really close here from our factory. It's about 30 kilometers one way when you take a route out there, and the look around from there is really nice. It's 1,600 meters of altitude, and it's actually we call it our Chasseral, Montchachon, which is a French word, Montchachon, and this is where we always see the benchmark of our engineering, of our production. So this where we see these Montchachon wheels, they're always the top-notch wheels. We always try to exceed boundaries. We always want to go further. So this year or last year, with a 25 years wheel set, we introduced a really light rim together with a new ratchet EXP hub on 180 bases, and we made really light spokes into it. So this year we achieved 1266 grams for wheel set for disc brake in a carbon wheel set. So this is really amazing. I mean, coming from aluminum, surely in 2004 we introduced the first Montchachon wheel set quite a few years ago, but now we are here with a full carbon clincher for tubeless ready, disc brake, everything. Really nice, and really nice to accelerate, and really nice to climb the Montchachon.
Very good. And who has the fastest time up Montchachon? I'm sure there's a DT Swiss internal competition going on.
Yes, you can find it on Strava.
Also find it on Check it out. Okay.
From the backside. And Savagnier is the start. It's about 7 kilometers, and we do a Montchachon race each year. And this year, because of the special situation, we made it virtually. But so we have this the Chasseral DT race. We have it in the Strava segment, so we always compare the best time. And surely you're right. It's Jan Oehlerich who holds the best time on the Montchachon.
Wow. Okay. Yeah, I know.
I'm not sure, but about 20 minutes, which is really fast. Yes.
Very cool. Very cool. I want to show a little bit about the wheels and wheel shapes. Obviously, you have worked a lot coming from aluminium and then now going into carbon. It's easier to create different shapes, and I think you have a very strong partner with Swisside from an aerodynamic side. But we have a few pictures of wheels, and maybe Will, if you don't mind, to start these pictures for us so we can get a bit of a glimpse of. Okay, that's obviously wind tunnel testing. Which is obviously today a quite important part, but maybe you can tell us a bit more about the wheels we see, Ralf.
So these are the new ARC wheels, the new Aero wheels we just launched in August. So they are for MY model year 21. They are available now and sold within the next years. Actually, these wheels were the first wheels where we only used the disc brake technology. So these were made for disc brake technology only. The last ARC Aero wheels, they were a mixture of rim brake and disc brake technology, but within the last 5 years, the bike industry has a lot changed. Even though people say, "Oh, it's another thing of the bike industry to sell more bikes," actually, it gives us more freedom. It gives us more security, more safety on the road, and we have more freedom also in creating new products, making them better, making them more aerodynamic, making them more controllable. This is one thing we were focusing on these wheels: controllability and keeping the aerodynamics at the same time.
I thought it was always interesting when you obviously look at an old wheel with a rim brake and you think you're braking on the surface, which at the same time holds the tire. It's quite a risky idea, because you never know. When I was in Germany, still we did a lot of mountain biking, and obviously brake surfaces were reduced because of the brake pad rubbing on the aluminium surface of the rim, and we had a lot of issues that obviously brakes failed or the rims failed. But now, as you said, with rim brakes and going to disc brakes, that this creates quite a high level of safety, because you're braking on a disc rotor and you can build different wheels and change it. And I think you just told me that you have a wheel set as well for bigger people getting overall a bit heavier weight. I think now the new weight limit is 130 on on a very, very specific set, where you have a system weight which is allowed this up to 130 kilo of a rider bike combination, correct?
It's not unusual to have this kind of weight. So I mean, 130 kilo, if somebody's doing bike packing, we are going even with a carbon wheel set and carbon gravel wheels to 140 kilos on the hybrid side. Yes. So we keep the aerodynamics, but make them more sturdy and the places where the driver needs it. But coming back to your first points, maybe just pointing on the rim brake systems. As you mentioned, the mountain bikers, they liberated them quite earlier, coming back from the V brake calipers down to the disc brake, and everybody said, "Oh no, I don't want disc brake. I don't believe in the system." But what's happening? Everybody is riding with disc brake, and so the same is principally happening right now. And imagine when was the last time like public transportation used braking on rims? Can you imagine when was it about? Must be like the horse carriages in the 19th centuries. So I mean, you're braking on parts that are for stability, that hold your weight, that you have to rely on. And so I think it was really time for a change to make riding also more safer.
Yes, absolutely.
And
we
so
saw
when we look at the rim shapes you just introduced with the pictures, you see the different rim shapes. So we have a earlier we had a more U shaped, which was really aerodynamic, but we also looked at the it's on the right hand side. On the left hand side you see the an older shape from the 90s, 2000s, and then we changed with Swiss side. You mentioned Swiss side also. This was on the right hand side you see the profile, which is the old ARC wheel set. Where you have also the braking surface, the rim braking surface, which was available for rim brake and disc brake. So we took the same profile for both rim brake and disc brake. And so what then happened? We were really fast. We achieved 3 wins on Hawaii with Daniela twice and with Anna Haug once in 2019, and they went with our wheels. I wouldn't say that it's because of our wheels, but these girls are obviously really, really fast, and you had Anna on your show as well. But this was one major step to an aero brand, and the next step was what's happening in the market. I mean, we have professionals, they are really stable. They ride 40 kilometers an hour. They like 45 kilometers an hour. But what's happening to the people on Hawaii, on other races, even training that to ride 30, 35 kilometers an hour or go downhill maybe with 60, 65 kilometers an hour. And then suddenly crosswind changes, crosswind coming into the wheel, and then you start shaking. And this is where people tended to say, carbon wheel, oh no, not for me, because it's difficult to handle. So this is where we looked with Swiss side, also with our engineers, what can we change? How can we change without sacrificing our aerodynamics? So the idea was to reduce the moment, the force on the side of the handlebar. It's called steering moment, actually.
We have another picture where we're looking at a few graphs, and maybe you can explain us and talk us through the graphs. And he said, okay, this is maybe the concern we get from a lot of customers. Thank you, Will. We get a lot of concerns from customers. Obviously, they said, now we get a high profile wheel, maybe I can feel it in the wind. But I have to say as well that your wheels are really, really stable in the wind, and you can really feel that the engineering really pays off, and you just have that feeling you have more control over the bike. And we have some strong winds here in Dubai, but I feel really you're doing a great job with this. But maybe you can explain us on the left-hand side the results of ARC when it comes to yaw.
So on the left hand side you see our different wheel sizes, the wheel heights. We have in blood red we have the 50 mils, and we have the 62 between that, and the 80 millimeters rim height and the bottom. And so when we see the 0 on the axis going up in the y-axis, this is actually the headwind you're facing. So when the headwind is straight coming into your face, onto your wheel, this is 0 degree of yaw angle. So this is where the wind hits you. So we see all wheels are pretty the same, staying in the same. But when it comes to the side wind, 15 plus 15 or minus 50, minus 20 of yaw, then you see the curve going down. Why you would say, how can the aero drag can be reduced? So on the left hand side you see how many watts you have to put into to overcome the drag. So from 15 watts we go down to minus 5 watts on the or even minus 7 watts on the right hand side. This is happening, and this is called the sailing effect. And the sailing effect is when the air sucks to the wheel and stays on the wheel and really gives you a thrust, a propulsion. Or can you name me any part of the bike, of the rider, including the rider, that gives you thrust without being doped? I mean, there's nothing. It's only the only component on the bike is the wheel that can produce propulsion. And you see this with the 80 mils, you have the biggest propulsion, but still you have also, when you look on the right hand side, you have the strongest steering moment. But we were able with the new RSC wheels to reduce the steering moment by far. So we came down with a new 80 millimeter rim height down to a steering moment of a 62 old rim height. So which is massively, it's a massive reduction of steering moment. So the handling really gets better. And when you feel it and when you ride it, and you have ridden it, obviously, you will see it's much better to ride and much more stable.
Very nice. You wished you had these wheels when you were in Hawaii a couple of years back. So How much faster
Yes.
do you think people are going today with the equipment you had in your time compared to if you had a proper DT Swiss wheel set? How many minutes you think somebody could save? If somebody says, listen, I'm doing an Ironman event and I have my aluminum wheels, and you said, no, listen, go for a set of 80 millimeter DT Swiss wheels when it's a flat course. How much money and how much money we're talking, and how much time is saving possible for somebody riding from a basic aluminum rim, changing to a nice DT Swiss carbon wheel set? What do you think? How many minutes in 180 kilometer?
It always depends on the wind. I mean, the more wind you have, the more you profit from the aerodynamics. When you're talking about Hawaii Ironman, then you have more crosswinds than on other courses, maybe. So this is where sailing effects can start and can be much stronger. So it's difficult to name it, but when we're talking like for a pro like Anne, we went with her in 2019, just before her Hawaii Ironman win, into the wind tunnel. We checked her aerodynamics. We looked at she had the best components on it. We gained about 15 watts of advantage on an overall system, which means about for her 5 minutes. So when we talk about the wheels, we probably can easily get 5 to 10 minutes only with wheels compared to a shallow aluminium rim. And it's really good point. You know, I was talking with Matthias from the DT, and a couple of days ago when we were in preparation of this meeting, he said, well, let's do a challenge. How could you be? What could be the margin gain or the time gain from your time to nowadays?
Yes.
So this is now the challenge we are talking about, and I think this is one thing we really want to pick up and see what is possible. What was the old time? What is now? I mean, this is probably really extreme when talking about the Centurion Overdrive of Thomas Hellriegel in 1997, I think, when he won Hawaii. But this would be a great challenge to see what were the abilities. But having it known, probably a couple of minutes. I mean, this is I was always asking myself, what did I do at that time? I looked awful on the bike. You know, people now sitting on the bike really smoothly. They have biomechanically backgrounds so much nicer to put the pedal to the metal and to stay in the aerodynamic position. It's incredible. And you know, as soon as you leave the aero position, go up, you easily make up 50, 60, 70 watt, which slow you down, and you have to overcome. This is fantastic to see. And this happened actually to me also Hawaii.
Yes. You have to have a lot of respect to the riders who didn't really understand. If we go like 20 years back and there was no real understanding of aerodynamic, it was more of a guesswork, and some people were faster, some were not. But what we see today, obviously, with all the testing and even for us as a normal rider in Dubai, we understand now so much more when it comes to aerodynamic and setup. We have a few nice pictures as well. You provided us to make more sense of aerodynamic. And Will, maybe if you start the Aerotrack picture we have, thank you. So that's maybe you can talk to us a bit about these pictures, Ralf.
So this is actually the direction of the rider. We are coming from the left and going to the right, and you see the wind coming from the front. This is where we talk about translational drag. Obviously, it's a surface the wind is facing. So it's not only the wheel, but it's also the components and the rider. We're talking about 75% other is the riders, 25% is bike components and everything around, which makes the translational drag. So it's quite significant in 25% where you can do some trimming, even on the wheel, on the bike, on the components. And on the wheel, we say about 8%, 8% of these 8% points of this.
Okay.
So here we have a graphic showing the idea of the sailing effect I pointed out before when we looked at the graphics, and this is what's happening when the wind is coming from the side. We have side crosswinds, and the propulsion is going into the riding direction and really gives you a push forward. So in the ARC 1100 die cut 80 mils, we have -8 watts. So we have 8 watt of gain. Really pushes you forward. It's not like the whole bike would now start to roll alone like a perpetuum mobile, mobile, but it's really helping you to push to go faster, and people feel this honestly.
No, absolutely. I can really say this, and we have so many customers who ride your wheels, and they really immediately come back, and a couple of days later they've been on the desert track in Alcudra and really say, listen, I'm a big smile and we're super happy, and it really performs. They love the sound, they love the extra speed, and it's so much easier for them to keep up with the groups and just put their new best time on these wheels. So very good. Maybe we see the next picture, Will. Okay, that's as well interesting. I think it was interesting to see the speeds the wheel are traveling. That obviously the top part of the wheel is going twice the speed of the rider. What you see on your speedo, obviously the front wheel is traveling at a very, very high speed towards the wind, and I think that's quite interesting.
Yeah, that's on the one side it's the translational drag, so it's a surface we are offering of tire dimension and our rim going into the wind. But the red arrow you see in the opposite direction is also showing the rotational drag by the spokes. So once you always have like the drag coming from the spoke, and this is why we say we don't look just on the translational drag on the surface of the whole system, but we also look on the spokes. This is why we made them thinner, we made them wider to give less drag for the rider.
Yes. Yeah. Very cool. Very cool. Yeah. And we've seen, I've now many years in the bike industry, like now 34 years in the bike industry. And I've seen at the beginning, it was always a lot of stories about broken spokes and everything. And I can tell you, this is a story of the past, having your wheels in the shop. It's only in an accident really when spokes are breaking. But before that, it was always a bit of an issue where it had a basic quality spokes, so that the stability of the rim wasn't really there. But now that's not an issue anymore. So that's an interesting picture, I feel, as well, where you can see the side wind and what happens.
Exactly. Yeah, we see the low pressure with the blue, and this is where on the front, on the leading rim, you see the sailing effect. On the left hand side, you see the blue wind is attached to the rim, and this is where the thrust, the propulsion is created on the wheel. This is really interesting to see these kind of images, which are mostly provided by the Swiss side, by our expert. So he's doing the CFD simulations before we go to the wind tunnel. He's obviously preparing this kind of graphics for us.
Oh, fantastic! Yeah. Fantastic.
And as you also mentioned about the spokes. You talked about the hand production in the Polish factory. So we have about 50 working stations where wheels are produced. We produce a lot of wheels, and every wheel, even though if it's a Montchachon wheel or just an entry-level wheel, it's all by hand produced. And this is what it makes so good. It's the art of hand building a wheel, and this is what makes it so reliable. And when people talk about hidden nipples or outside nipples for exchanging and J-bend spokes for easier exchange, we can say, hey, listen, our wheels are hand built, and normally, as you said, if you don't have an accident, you don't have to retool the wheels, because they're really a lot of times de-stressed, they're hand built, and the quality of the spokes just holds.
Yes. No, absolutely. You're right. And then you maybe think you need a nipple to be outside, but you really don't need it, because you don't need to true the wheel. It's built once and it's built to perfection. And then there's no more talking around. Very good.
And we're talking also about aerodynamics. I mean, the nipple is a small part, but we measured it up to 0.5 watts. Okay. So looking at the rotational drag, looking at the nipple drag, 1.6 watts already. I mean, these two small parts.
You don't want to leave it out on the road just for no reason. Yeah, you rather hide them. No, that's true.
Exactly.
Another big thing is obviously with disc brakes now we see that rims got wider and obviously tires got wider. And when I'm sure when you were in Hawaii, you had 18 millimeter or 20 millimeter tires.
I'm not that old. Okay, I started with 18 millimeters. I think the Conti competition or something, which was really a slick tire I rode at that time. But on Hawaii, we were talking probably about 20 to maximum 23 millimeters, and the rims were not that wide as they are today. Yes. And it's also again a theme of liberation coming from rim brake calipers cantilever calipers now to disc brake technologies, where you have more freedom in creating more voluminous tires. And when we see where mountain biking is, for example, I mean, they ride 2.3 inch wide tires and even more wide tires. And this, nobody could imagine having such big tires. And the same is happening actually in road cycling as well. We get wider tires because we see, we can compress the tire more easier. We have lower rolling resistance. But now we have to look on compromising aerodynamics. So when we are talking again about translational drag, we have to see the frontal surface. If we make a tire really wide, we get surely more translational drag. But on the same time, the rolling resistance might be reduced. So we must look at the compromise, and this is why for the new wheels with a 20 millimeter inner width on the ARC 1100 die-cut wheels, we propose a 25 millimeter in the front for perfect aerodynamics. This is measured in the wind tunnel, and we propose 28 millimeters for more comfort, less rolling resistance in the back, because you also have more weight on the back.
We have a nice picture, I think, which explains as well how the tire connects to the road. Maybe, Will, if you bring this up, the last picture we have of the tire size, picture number 5. The tires tubeless. That's a nice picture to see. Then obviously we go with a wider tire that instead of being long and narrow, you get a more oval shape picture. Yeah. I think it's a single. Okay, that's very interesting as well. A lot of people obviously afraid when the wind comes from the side that the handlebar would shake and the steering moment would be affected. But as you mentioned, you obviously adjusted this and worked a lot that the stability is much higher now. So people shouldn't be afraid to use a 60 to 80 millimeter front wheel. That's not an issue.
No, it's our AeroPlus concept we are following here. So on the one hand, we want to stay aerodynamic as possible, as good as possible, but also increase handling. Yes. Nevertheless, if it's just an endurance rider doing a Gran Fondo, doing a ride in the weekend, doing the ride during the week, or the ambitious cyclist, ambitious triathlete, for example. And so this is when you look at a triathlete leaning on the handlebar, you have quite narrow your arms together. So when a crosswind comes and a gusty crosswind comes onto the wheel, then you have quite a few forces put on the handlebar, which can produce a shifting on the road. So it's like passing a truck, for example, which passes you. And this is where we look at the steering moment. And the idea is to have the rim constructed that the force of the wind is more evenly distributed over the rim to reduce the force on the steering axis. And the closer I get to the steering axis, which is the center of pressure, the less impact I have on the steering moment and the less counterforce I need to apply to stay on my aero position. And as I said, if you leave the aero position, you open 60, 70, 80 watts, you lose time. Bam.
Okay, that's very interesting. Yeah. How much you work? You mentioned Swisside before. How close is the cooperation with Swisside when it comes to all this area? He's obviously a big brain behind all Formula One technology and so on. So what is the next big thing we're missing at the moment? Obviously, we went from 20 millimeter tires, 23, 25, 28. What's the next big thing you see coming from the wheel or tire side and everything like this? What's the next big surprise we can expect?
I mean, with the new ARC wheels, we really put a big surprise already on the market. I think they are well received. We left the image of being ARC wheels just in the triathlon, so a lot of road cycling love the wheels. So this is why I think we have been doing a lot of work in the recent 3-4 years to come to this moment and to show this. We obviously have the possibility to ride wider tires, and I think there is maybe a possibility of wider tires, but it's always depending where I ride. Do I ride long distance? Do I look for aerodynamics as a triathlete? Then I have to find a compromise on the tire size. But if I'm out for comfort, long distance traveling, then I don't look for the ultimate aerodynamics, sometimes more for comfort. and then I go wider with the tires. But currently, when we see in endurance riding, we see 30, 33, 32 millimeters. This is probably the dimension we see currently. And here, this is our propulsion where we were talking about this. Our former wheel, which is 70 millimeters on the left side, the ARC from the 2017, 2018, where we had the 23 millimeter tire on, which had a really long patch on the surface. And this is it has much higher rolling resistance than you see on the right hand side with 25 to 28 millimeters, where the patch is smaller. You have a deformation of the tire, and this is where the rolling resistance is reduced. So when I also leave out the inner tubes, then I have even better lower rolling resistance than before when I used inner tubes.
Okay.
Which is still common in the road cycling, but meanwhile we see more and more tubeless technologies come, and our wheels have been all compatible tubeless ready since 2016, including the component rims. Yes.
So you see a big push towards tubeless, obviously, because the tube can't burst. You have a tire system which is sealed, obviously, inside, and you have the milk maybe inside to make this work in a better way. So you're pro tubeless setups for your mountain bike and for your road wheels.
I mean, again, it's like the disc brake for bicycling industry. Again, mountain bikers were ahead of the time. Well, they're using for them it's standard to use tubeless technology. Somehow riders are afraid of putting on the tires. They say, oh, it's difficult to put on the tires, but we see a lot from tire industry showing that there are really good tire levers to put on the new tubeless tires without harming the rim. And this is something sometimes where people think, oh, shall I do this or shall I do it not? If I'm out there riding out in the desert, for your place, for example, or here up in the mountains, and then you have a really big pan, then you have to change it. Then you maybe have to put in a tube, and then you have to rely on the material. You have to rely on the lever to take out this. But I think this is only a question of time when we have this. And I think also the broader tires make it easier to ride tubeless because they're less stiff.
Very good. So if a customer comes now to the shop and said, okay, listen, I'm in the market, I have my racing bike, I have some more basic, maybe the first OEM wheels on my bike, so now I want to upgrade my wheel. So where do you think is the best thing to start? Where would you say, as a professional, what questions do we need to ask them, and what people need to think about when they're going to purchase their next wheel set? How should they go about that?
I mean, I wouldn't tell them to purchase a disc brake bike if he has a still on rim brake. That's my first thing I should look on. And so this is the first limitation. Look what kind of the braking technology I have. What rim do I ride right now? Am I satisfied? Where do I want to go? Want to go more hilly? Want to go more flat? Do I want to be more aero? Then I have to go on higher rims. So this is this question that you have to ask him. Okay. And also about how safe is he when he's a really safe rider, maybe a little bit more weight, and he's really stable and he can ride really fast. And you can say, okay, you take a 62 millimeter front wheel, back wheel. It's a really good general wheel where you have super performance, super aerodynamic, good handling, a good steering moment, but you can go really fast with this. When you're not that safe in conditions in riding, if you are more a starter, then I always would propose to take a lower rim height.
A little bit of lower rim, okay. And as we said, aluminium has still a good market for climbing. You have the good braking surface, especially maybe if the weather is not so good and you have maybe rougher roads. The wheels are as well tubeless. The aluminium wheels are all tubeless as well.
Everything, yeah. All the wheels we have in road cycling tubeless ready, except two exceptions, for the track wheels and one for the cyclocross wheels, where we still have two rims with tubular.
Okay. And I think an interesting wheel, you showed it me before, is the one which is for the riders 130 kilos. I think that's quite an interesting. Before, the other wheels are around 110 kilos system weight.
Mm-hmm. So 110 is the new ARC, the disc brake technology, coming from the same system weight. When we are walking always to the ERC wheels, for example, the endurance wheels, it's 120. And out of the ERC, out of the endurance wheels, we developed last year series for the hybrid wheels for actually made for bicycles with a motor assistant for e-road bicycles. This is why we call it hybrid. Hybrid is our naming for everything which is related to electronic, to motor drive. And these wheels actually use the same rim as the RC 62 I just presented to you. So the only thing what we did more, well, a couple of things we did, was we have more spokes. Implemented more spokes for better stability. Because normally you put more force, more torque on the rotor, and you have different spokes. You have hybrid spokes, and you also use a different rotor, which is a steel rotor. So stronger steel rotor. You gain a little bit of weight, but actually the aerodynamics of the wheel is really good. Talking about 130 kilos, it's easy. I mean, a man, a woman, 1.90 meters, 95 kilograms, you easily reach more than 110 kilos with everything on it.
Yes. So system weight means the rider, as you go on the bike, you put yourself with the bike on a scale, and then you hope that it's not more than 130. Then you're good to go.
Even the water bottles.
Okay, everything should be on there. Okay, the backpack or whatever.
Backpack, yeah. So this is quite common to reach this kind of weight. So carbon is not only for light people anymore. We have carbon for everybody.
But would you say that carbon people bear a risk of having a broken wheel? Do you see that some people say, okay, carbon and maybe it breaks easily, but from what is your experience from aluminium to carbon wheels? Do you see any more issues with that?
No, it's carbon is really very stable, very reliable. I mean, if you have a crash, then also aluminium breaks or bends. So this is there's not a big difference. I think you can really build very stable carbon rims, carbon wheels, and they're all tested in our premises. So we have a performance test center where we test everything. We meet the UCI test, but we mostly exceed it because it's our expectations to have it safe for the customers.
Okay. As well, speaking safety and about warranty, if I buy a wheel from DT Swiss, obviously it's quite an investment. If I have the unfortunate process of having an accident, what's the policy on these things? Is there kind of a crash replacement, or is there anything you offer like that?
Since 2020, we have a fair share policy. So when something is happening and you're the first owner of the wheel set, we replace the rim, or we do the repair for the wheel for a fixed base, for a fixed sum, which is quite low compared to a whole set. You should then reinvest.
Okay, that's good. Very good.
But you all find this information on dtswiss.com.
Oh, very good. Which is actually a super comprehensive site, and it's really interesting to look into all these products. It's quite interesting. Very good.
Yeah.
Listen, I think you've been one of my most prepared guests in the show, and we talked a lot before this, and I thought it was really interesting, and as well thank you so much for all the samples you have shown us, and I think it's really we're really proud to be associated with DT Swiss. I think you guys do really good things, and I think it's interesting that you as well produce for a lot of other companies in the market. Bontrager, Specialized, a lot of things. Every time we open a wheel, we open these things. I think you really keep the bike industry rolling from Switzerland. So I think thanks in the name of all the riders using your fantastic products. And again, thanks for your time, Ralf. It was really interesting. And I'm looking forward. Hopefully soon we can travel again and we can come to Switzerland again to see all of this. In the same town, you're in Biel, and there's as well Rolex as well. There's obviously people love the Swiss product. Is this you're close to the Rolex factory?
It's like 500 meters. Yes, about.
Okay. So the really good stuff comes from that place.
Definitely, yes.
Very good, very good. That's interesting. Yeah.
No, thank you also for having us on the show, and thanks for representing us so well in your region.
Yes, thank you.
Looking forward hearing you again.
Yes, very good. I hope to see you maybe at the Ironman. We hope next year we're going to have the Ironman again, and we're going to have a presentation there. So we're going to see you there, and people can obviously come to test wheels in the shop, and we have the test sets there. And if you want to go a little bit faster, and we learn now you can sail on the wind in Dubai. So then DT Swiss wheels are your choice. Very good.
Thank you very much.
Thank you very much, Ralf. Thank you, everyone. everyone, and stay tuned. We have some interesting guests coming up from Design, from DT Swiss. We have some interesting people coming. So stay tuned, and thanks for watching again. Yeah, thank you, Ralf. Regards to Switzerland.
Bye. To the bye.
Thank you.